In this video, we're going to practice drawing condensation polymer from these two monomers. Before we do that, we're going to spot commonly made mistakes in a given answer. How many errors do you think you can spot in 1 minute? Here's the question. We need to provide the condensed structure of a polyamide from these two monomers. One containing amino group, which is the NH group, and one contains the carboxyl group, which is the COOH. We need to condense out water from these two groups. Here's the given answer for the condensed structure of the polyamide. I'm going to give you 1 minute to spot as many errors as you can. I'll start the clock, and then we're going to compare notes after that 1 minute. Ready? Go! Alright, time's up. If you need more time, go ahead, pause the video. If not, we're gonna go ahead and get started. How many errors did you find? I found 5. We're gonna start from the left. The first error is here. When we condense out water, we only remove one hydrogen from the amino group. This structure is missing the other hydrogen. We have NH2 group, so we only remove one H. There should be one more hydrogen present. The next error is here. There should be a CH3 group connected to the second amino group. Notice that line that comes out from the given monomer. That line is actually indicating a substituent, which is the metal group. CH3 connected to that nitrogen. The next one is the benzene ring. Do you see the difference between the two benzene rings compared to the one that's given in the monomer? It's not connected correctly. That's actually a common mistake. Next is this. When we remove out water, we take OH from COOH group. That means the end part of the monomer should only be C double bond O. That O that I've highlighted should not be there. And last but not least, the 5th error is this. For condensed structure, we need to have the square bracket, which is present in this structure, along with a lowercase n. However, it's missing in this given structure. So let's look at how we draw the correct polyamide. We're going to start with the amine, the first monomer, and then we place the second monomer, carboxylic acid, right next to it. To condense out water, we remove H from the NH group, and we remove OH from the COOH group. We do the same for the NH and the COOH on the ends. So we will remove a total of 2 sets of water molecule from the two monomers. Now all we have to do is connect the N to the C double bond O. Don't forget the 2 ends as well. Polymers should always have open-ended bonds on both ends of the structure. That's to indicate that the repeating units keep repeating itself over and over and over. Since we are drawing the condensed structure, so we need to include the square bracket like that. And then we also need to indicate that lowercase n at the bottom to indicate that it's a polymer. Now, depending on the types of polymer, n could be a value of like 10 or hundreds of thousand. The bond that we form to connect the two monomers together, that's called the amide linkage. Since it forms C double bond ON, that's an amide group. And with that, we're done drawing the condensed structure of polyamide. Now that amide linkage that I've drawn is slightly long. It's just to illustrate to you. When you draw out your actual structure, go ahead and shrink that bond so that it's regular size. With that, we're done drawing the condensed structure of polyamide. Here are the 2 videos I've handpicked for you. Thanks for watching all the way to the end. If you find this video helpful or you enjoyed it, be sure to like and share it with someone. Don't forget to subscribe. Your support means a lot to me.